Hello everybody. I hope I am visible and I am audible. Coming down to this particular question, this particular this particular concept, this is concept number 4 that we're talking about. It says multiply factor based or percentage increase or decrease. This is a very standard thing which we've already talked about. If there is any increase in percentage, so what we have to do is we need to have a base. We need to have a base against which the calculations would be done, and against that base we have to keep the increased or decreased value and then multiply it by 100. Then we can declare that this is the percentage increase or percentage decrease. Percentage increase and percentage decrease collectively can be called percentage change. Okay, so whatever is happening in this third equation over here, this is nothing but a generic statement of the above two equations. Okay, so there's not much to understand over here. It's just that always keep the base constant and always try to remember on what base I'm working, because if you commit a mistake in choosing the base, trust me, it doesn't really suit. Like, it would not lead you to the correct answer. It would not lead you to the correct answer. And if you do not, like, it's very commonly said that you need to strengthen your base, strengthen your basics. So it is said because of a really strong reason that if you go wrong with the base, you mess up with the question. Okay, moving on. This is the question we have. A basket contains 350 eggs, and if 12% of the eggs are rotten, how many eggs are good enough to be sold? Okay, how many eggs are good enough to be sold? So, being optimistic and being students of mathematics and also studying the percentage chapter, I've told you, because of optimism, you need to assume one thing. The assumption is that whatever you have is 100%. So, let's assume the number of eggs 350 is equal to 100% of the eggs, and it says 12% of the eggs are rotten. 12% of the eggs are rotten. In this manner, I have a full set of 100%, and some of them are good eggs plus some of them are rotten eggs. Some of them are good eggs, some of them are rotten eggs. So if rotten is equal to 12%, and I take this 12% on the other side, the plus 6 sign changes to minus sign, and 100 minus 12 would give me 88%. So I'm gonna write 88% over here, 88% over here, and this 12% is the number of rotten eggs or the percentage of rotten eggs, and 88% is the percentage of good eggs. So the question says how many eggs are good enough to be sold. Okay, the good eggs are 88%. Again, using the unitary concept, 100, if 100% of the eggs is equal to 350, what is 88% of the eggs? So 350 divided by 100 multiplied by 88, this would create the final answer. Okay, let me cut it like the big boy or the big girl cancellation policy, or the big girl factorization policy. Okay, the big girl or the big boy factorization policy says use the biggest possible number. Okay, so 52s are 100 and 57s are 350. So just look, we've very clearly eliminated the biggest of the big numbers here, and we've come down to a very easy solution. Now 2 fours are 8, 2 fours are 8. 7 multiplied by 44, 7 fours are 28, another 2 goes up, 7 fours are 28, 28 plus 2, 30. 308 are the eggs which are good enough to be sold, or good enough to be consumed, or good enough to be sold. Yeah, that's the question. So I hope you got it of what concept I'm taking from where and what's going on here. Okay, moving on. This is a very good question, and particularly I would really want you to focus. I really would want you to dig in and see what's going on here. Okay, it says increasing 110 by x percent gives the same result as increasing 50 by x percent. Okay, decreasing 110, decreasing, I might have misread decreasing with increasing. So it is decreasing 110 by x percent gives the same result as increasing 50 by x percent. Then x percent of 650 is what percentage more than x plus 20 of 180%. This is bit of a calculative question. Okay, I am already giving you a warning. Calculative. This is a calculative question, and if you have some patience, if you can gather a little bit of courage and a little bit of patience, trust me, this question you'll be able to sail through very easily. Okay, now let's start off solving it. The decrease by x percent, the decrease by x percent can be written as 100 minus x. Agreed? This is equal to, because it says gives the same result as an increase by x percent. I hope all of you agree of whatever I'm talking about. Here's the percentage sign and here's another percentage sign. In the first equation on the left hand side, it says decreasing 110. So 110 is being multiplied over here, and here increasing 50. So 50 is multiplied over here. So the base of our question has been set. Now we need to find out the correct value of x and plug it in into 650 as well as this 180, and then we'll be able to figure out the correct solution. Okay. Okay, so this in this particular question, as I've already discussed, that there is a decreasing factor of x. There is a decreasing factor of x associated with 110, and there is an increasing factor of x associated with 50. And this is the first equation that you have to deal with. You will get you'll get the proper value of x over here, and then you have to put the same value in the next equation to find out the relationship between 650 and 180, which has one more level of complexity involved with it. Okay, and the complexity which is involved there is regarding x as well as x plus 20%. So it's very important that we should play very smartly with x. Okay, so let me first find out the value of x and then we'll play pretty smartly with x. Here on the left hand side and the right hand side, there's a percentage sign here, there's a percentage sign here. I'm going to cancel that out. I'm going to directly write, or I will have 100 in the denominator, and the 100 would get cancelled out. So it is directly 110 multiplied by 10, 100 minus x, then 100 plus x multiplied by 50. Okay, I will take this to one place. The number should be on one place, and the things with variables would be on the other side. The left hand side and the right hand side are completely separate. So what you see here is a combination where to find out the value of x, we can solve it using componendo and dividendo. Okay, we can use C and D, or very clearly we can use componendo and dividendo. For those of you who don't understand what C and D or componendo and dividendo is, I'm going to write it here. If there is something called a by b and x upon y, I can write it as a plus b upon a minus b is equal to x plus y upon x minus y, and this whole thing shall be equal to a upon b, uh, shall be equal to a plus b upon b, or x plus y upon y, or it could be equal to a upon a minus b is equal to x upon x minus y. Okay, I hope you understand this sort of a combination. These things would be separately equal to each other. Okay, there is no equal to sign in the middle. I drew it by mistake. So this is called componendo and dividendo. How componendo and dividendo helps us, I'll tell you what. It's 100 plus x upon 100 minus x. If I start doing the calculation, I will have to multiply 110 multiplied with this by this entire equation, and 50 multiplied by this entire equation, and then I'll have to take the x's at one side and the numbers at the other side. So it increases my calculation. if there is a concept which I know which would reduce the calculation tendency and and the latency and the slowness and the decrease in speed which comes because of a lot of calculation, you will be relieved by it. Okay, it would produce a lot of friction in your mind if you have a lot of calculation to do. So what I am doing here is, now I am going to use componendo and dividendo, which brings my answer to be 100 upon x is equal to, the 0 gets cancelled by 0. 11 plus 5 is equal to 16, and 11 minus 5 is equal to 6. Okay, so I'm gonna solve it here itself. 2 8 is 16, 2 3 is 6. So the value of x by 100 is equal to 3 by 8, or 37.5%. People in the comment section, please tell me how did I come down to 37.5%. In the first video itself, I told you we need to learn uh, some of the few um, percentage and ratio formulas that are present. So in the same manner, 1 upon 8 is equal to 12.5%. Okay, 1 upon 8 is equal to 12.5%. So 3 upon 8 is equal to 12.5 multiplied by 3, that is 37.5%. Now we'll be using this output to our rescue for the upcoming answer. Okay, I am just rubbing off the componendo and the dividendo component, or no, let me solve it here only. If I don't get space, I'll solve it on the next questions page. So I have the value of x as 3 by 8 or 37.5. Now it is saying I need to solve. I'm changing the pen color. At least you get to know what I'm doing. What is happening here is x percent of 650. Okay, so I'm gonna solve it here. 3 by 8 of 650. That is 1. I'll just solve it immediately. 8 8s are 64, and there's this 10. 8 1s are 8. 8 8s are 64. 8 1s are 8. Now 2 is there. Okay, then 8 2s are 16 and 8 5s are 40. It's 81.25 multiplied by 3. So we have 75 here. 3 1s are 3. 3 8s are 24. It is 24.7 to 243.75. This is the first thing that I have to keep in mind. And secondly, x plus 20 of 180. Now here 20% is also in the equation. So I will write 20% as 1 by 5 plus x percent is 3 by 8. I have to multiply this by 180. Okay. 5 3s are 15, 8 1s are 8, 23. 23 by 8 into 5 into 180. I hope you're able to understand what sort of calculations I'm doing here. 4 9s are 36, 4 2s are 8. And now 9 with 23 divided by 2, or 9 3s are 27, 2, 9 2s are 18, 18 plus 2, 20. 20 upon 2 and 103.5. Okay, 103.5. This is the second thing. Now I have to derive a relationship between 243.75 and 103.5. Now I'll be applying a sort of a smart trick to either reach 136% or 154%. It says this bigger number is what percentage of this smaller number? This is the question over here. One very clear outcome that we have here is, if I multiply 103.5 into 2, the answer that I get is 207. and 207 is still smaller as compared to 243.5. So the values which are less than 100% are automatically cancelled out from the equation. Now I have another milestone to achieve, and the milestone is that I have to check if my answer is above 50% or below 50%. So 50% of 103.5 is equal to 51.5, or you may take it as 50 as well. Okay, the 50% of some of a value which is closer to 100 would be 50 only. And in 207, which I have achieved in the past, if I add 50, the value comes out to be 257. The value comes out to be 257. But my value here is 243.75. That means anything which is near 50 or beyond 50 is of no use to me. That is why the final and the correct answer is 136%. Okay. If you want me to do the entire calculation of this, I'll help you do that as well. I have to check what is 243 of 103.5. I will first subtract 103.5 in this equation, and I have 0.25, then 0, then 4, then 1. So I'm sitting at 140. I'm sitting at 140.25 divided by 103.5 multiplied by 100. It's clearly an answer of anything above 100%. And to check if it is above 50% of this quantity in the denominator, the answer should have been above 257 or above 157, but we are sitting at 140. That is why the answer 136% is the correct answer. Okay, so this is a smart suggestion which I would give you. If you cannot achieve the answer through this, try the other way out. I'm going to explain this particular question one more time, because this is where we end concept number 4. The question said, if decreasing 1110 by x% gives the same result as increasing 50 by x%, then x% of 650 is what percentage more than x% of 650 is what percentage more than x plus 20% of 180. Okay, I'll be using the green pen and try to give you the cues of what all steps did I take. Okay, the first step I took was 1110 multiplied by 100 minus x, which is the decreasing factor using x. This 100 plus x is the increasing factor using x. Now to solve this, here I remove the percentages sign. Now ahead, here I used componendo dividendo in C point. I've already explained componendo and dividendo here. Okay, I will componendo and dividendo here. Componendo and dividendo I have explained over here. Okay, I use the same thing to achieve the value of x or x%, which is equal to 37.5% or 3 by 8 in in fractions. If you'd see here, the first answer which I came out with, this is the first equation I came out with. The first equation I did not use 37.5. I still hung on to using 3 by 8, because solving answers using fractions is an easier way out instead of using the full percentages itself. 3 by 8 multiplied by 650 would give me 243.75. And then I went on to the second equation, which was related to 180. Here also, I still used fractions. 3 by 8 plus 1 by 5 multiplied by 180. Moving on, I did a quick calculation and I achieved the result, which was my second equation. Okay, here I have written 2, here I have written 1. So I have the first answer and I have the second answer. Now I need to compare that how much percentage is the bigger number of the smaller number. Okay, I'm writing big here and I'm writing small here. how much percentage is the bigger number of the smaller number. So after seeing that 103, even if multiplied by 2 is lesser than 243, I could eliminate two options that the answer would definitely be above 100. Now, one of the answers is above 50% as well, and the other answer is below 50%. So I checked if the 50% of 103.5 is anywhere near 243. So when I multiplied 1 by 103.5 by 2, this is the 100% that I'm talking about. And this is the 50% that I'm talking about. Okay. So my answer was nowhere clear or nowhere close to 257. My option was 243. So instead of choosing the bigger number here, this is the bigger number here. I chose the smaller number. I chose the smaller number. And this is how I arrived at the correct answer. Okay. Thank you.